Hello everyone. In this video, we'll see what are the evolution of systems in the wireless communication and what is called FDD and TDD. Okay. Now, first thing is that this evolution has been divided into three kinds: 1G, 2G, and 3G. In between, we have 2.5G as well. Okay. Now, first we will see what are 1G systems, then we'll go for 2 and 2.5G. Okay, now 1G systems are called AMPS. These are called Advanced Mobile Phone Services. Okay, those are called Advanced Mobile Phone Services. Okay, so they are only used for voice traffic. They are mostly used for voice traffic. Okay, what type of technique they used is FDMA by FDD. FDMA by FDD. Okay, I'll tell you what is this FDD and what is the difference between FDMA and FDD in the later part. So the technique they used is FDMA by FDD. Okay, and those are already designed for voice traffic. Okay, they used digital schemes. Basic digital schemes, not the advanced one. Okay, now this is about 1G or advanced mobile phone services. Next, coming to 2G, second generation mobile systems. They were designed for voice traffic, okay, and also few lower data bits. They are also designed for voice traffic and also data rates. Also for data rate. Okay, these systems they used digital modulation techniques. Digital modulation techniques, okay, and they used TDMA and CDMA multiplexing techniques. Both were under FDD. You can say plus. Okay, TDMA by FDD and CDMA by FDD techniques. Okay, and these 2G systems, they were not concerned about speeds of the data rate. Okay, they were not concerned about the speeds of the data. Whereas 2.5G, okay, 2.5G is for voice plus low data rate. Voice plus low data rate. Okay, they were using GPRS scheme. GPRS is called General Packet Radio Service. Okay, they were using GPRS scheme. Okay, now there is other thing called GSM. Other mobile system called GSM, which is called Global System for Mobile Communications. They used both, as I mentioned earlier, TDMA by FDMA, both the multiplexing techniques. Okay, they had two frequencies, generally 900 and 1800 megahertz. Okay, so whatever mobile phones which we see today has, if you observe, they have two antennas on it. One is visible from the outside. Okay, other antenna will be on the, if you remove the back cover of the mobile phone, you can see a patched antenna. It's called patched antenna. This is designed for 900 to 1800 megahertz. Okay, this is designed for 900 to 1800 megahertz. Okay, So here, if the frequency which we are using is more than 900, then this antenna will be activated. If not, 900 megahertz, that antenna which is designed for 900 megahertz will be working. Okay, so these are the systems. And 3G, I'm sorry, 3G is both voice plus internet plus few of the multimedia users. Okay, these have high data rate, also high data speed. Okay, up to Mbps, 10 Mbps and okay. Now next, coming to few systems called duplex, or half duplex and full duplex systems. Okay. Now here I have called system called half duplex. What does it mean? Okay, it means half duplex system is a system wherein both transmission and also receiving is done at the same instant of time. Okay, so that means this can happen, transmission and reception can happen at same instant of time. Okay, that means at any one time we can either transmit or receive. Okay, we cannot send, transmission cannot happen at the same instant of time. At one instant of time we can transmit or we can receive the signals. Okay, this is called half duplex system. The example of half duplex systems is the police have the cordless phone type. Okay, those are the examples of this half duplex system. Okay, like at one time of instant only you can speak and you send an acknowledgement called over. The other person will receive it and he sends back the message at the other time instant. Okay, that is the example of half duplex system. Similarly, we have another system called full duplex system. Here both transmission and reception of a signal can happen at same instant of time. Okay, that means here I am using a device called duplexer. Duplexer is used as a switch here. Okay, so it enables us to transmit and receive the signals at the same instant of time. Okay, so using this concept for the full duplex concept, it is provided by two different access systems. Like it is provided by FDD and TDD. Okay, frequency division duplexing and time division duplexing. Okay, these are different from the FDMA and TDMA. These and these are not similar. Okay, people need to be aware that FDD and TDD and FDMA and TDMA are not similar, because this FDD and TDD, they refer only between the communication between the mobile and base station. Okay, for this purpose we use FDD and TDD. Okay, these are only referring to the communication between mobile and base station, whereas FDMA and TDMA are referring to the channel division in a particular spectrum or particular band of frequencies. Okay, this is referring to the channels, whereas this is referring to the communication between mobile and base station. Okay, so these two are completely different in their respective aspects. Okay, now, so to achieve full duplex, there are two types of access, two types of divisions we have. One is frequency division duplexing, other is time division duplexing. Okay, now here when we have frequency division duplexing, that means for a frequency division duplexing, both base station and subscribe unit are base station and subscriber. Okay, this can transmit at time instant t1, this can receive at time instant t1. Okay, at the same instant of time, both can transmit and receive the signals. Okay, but here what happens is, at the base station we have two antennas. The base station we have two antennas, one for transmission, one for receiving. Whereas at the mobile subscriber, at the mobile unit, we have only one antenna. Why one antenna? Because we are using a device called Duplexing here already to switch in between the receiving and transmission. Okay, so we need only one antenna of the mobile unit. Okay, this is for FDD. Now here, next is for TDD. Here, what happens is, in a time division, whenever we find time division, it is just the sharing of the time slots. Sharing of the time slot. Okay, that means, suppose I have the radio channel of frequency and time. I'll make this into time slots. At time t1, t2, t3, t4, t5, t6, t7, up to so on. Okay, it is possible to share a single radio channel into the different time slots. Okay, now what happens is, some part of time is used to transmit the signal from base station to mobile subscriber, and some part of time is used to send the information from mobile subscriber to base station. Let's say here T1 is time, this will be T2. Okay, but the interesting thing here is, this TDD uses digital modulation technique. Okay, and as it is using this time slots thing, so it is only applicable for less distant application. Okay, for far distance it might not be giving an effective result, but for less distances it will provide us the best results using these digital modulation techniques. So that's all for this video. The next video we'll see what is called Alahua. Thank you.